All right, everyone. Hopefully you are having a good evening so far. We're going to go ahead and take a look at the Unit 4 study guide, as well as the multiple choice bonus study guide that I posted this afternoon, just to get us ready for our Unit 4 test tomorrow. So let's just jump right in here. Taking a look at number one, we have x squared minus 4x plus y squared plus 4y plus 3 is equal to 0. And we are looking for the center of the circle as well as the radius of the circle. Now, the very first thing that I like to do, and you guys did a great job of this in class, I like to just move this 3 over to the other side. It's just going to make up some space for us as we're working with what we've got here on the left-hand side. So I'm looking at x squared minus 4x plus y squared plus 4y is equal to negative 3. The reason why this is really, really nice is because I'm ultimately aiming for this. I'm ultimately aiming for this form x squared minus 2hx plus h squared. You'll notice there's a little gap there. Plus y squared minus 2ky plus k squared, which matches to the gap that we have there. And so I'm going to use this to find h and k, and then once I have h and k, I'm going to use this to figure out what r is. So this is going to be offset from r squared. So in this case, our value of h is going to be this linear x coefficient negative 4 divided by negative 2. So for h, I get a value of 2. And for k, taking this positive 4 dividing by negative 2, I get a k value of negative 2. And that already is our center. This is going to be positive 2 for the x, negative 2 for the y. But I'm also needing to fill in these gaps, and these gaps are filled in with an h squared, which in this case is 4, and a k squared, which also in this case is 4. So we'll go ahead and add in a 4 to both of these gaps. Now, if I'm adding something to the left-hand side, I also have to make sure that I'm adding to the right-hand side, which tells me on my left hand, or sorry, not on my left-hand side, on my right-hand side, that I have 5. Now, we know that that right-hand side is r squared, and so we can deduce then that the radius is going to be the square root of 5. All right. I'm going to take a look at number 3 next. Number 2 is kind of more like the mechanism in order to figure out number 3. So if you can do number 3, it kind of requires you to be able to do number 2. So it's kind of a nice all-encompassing one. In this case, we're looking at sine of 13 pi over 3. Okay, we know sine of pi over 3. That's going to be a unit circle angle. Sine of pi over 3, those are either going to be plus or minus the square root of 3 over 2. Depending on which quadrant we're in, we're going to go with the positive square root of 3 over 2 or the negative square root of 3 over 2. But we don't know which one of these to choose because we don't know what quadrant 13 pi over 3 is in. So we need to find what angle is coterminal with this particular angle. The way we find coterminal angles is we can add or subtract 2 pi as many times as we want from an angle without changing that xy information, without changing its quadrant location. In this case, because my 13 pi over 3 is over-rotated, I'm going to subtract away a kind of convenient version of 2 pi, the 6 pi over 3, convenient because the denominators match, which gives me 7 pi over 3. Now, 7 pi over 3 is also not an angle that we recognize, and so I have to repeat this process over and over again until we finally do see something we recognize. In this case, I can stop at pi over 3. The quadrants of 13 pi over 3 and pi over 3 are the same. We know that pi over 3 is a quadrant 1 angle, and so we are going to say that this is positive root 3 over 2 because sine is positive in quadrant 1. Take a look at number 5 here. So we are told that sine of theta is 24 over 25, and that theta is in the second quadrant, and we are looking for secant of theta. All right, so this is not unit circle information, but this is right triangle information. So this is our hypotenuse. This is our opposite side since we are looking at sine here. And so looking at our triangle, if this is my theta, opposite side is going to be 24. Hypotenuse is going to be 25. This is actually a Pythagorean triple. If it weren't, then we could say that a squared plus 24 squared was equal to 25 squared. But when we solve for this, what we're going to get is that a is actually equal to 7. And so secant, which is, you can think of it as 1 over cosine of theta, that's fine, but I don't love fractions inside of fractions. So maybe a better way to do this would be r over x, or hypotenuse over adjacent. In this case, that is going to be 25 over 7. But we also have to take into account the fact that theta is a quadrant 2 angle, and x in quadrant 2 is negative. All right. Taking a look at number 7 here. We are trying to find, given that we have a circle with a radius of 5, we're trying to find the arc length that is associated with 250 degrees, subtended by 250 degrees, is like the technical verbiage. My method for this is to kind of think proportionally. So we had all of these proportions that we knew to be equal. For instance, if I have theta in radians out of 2 pi, I knew that that was the same as my theta in degrees out of 360 degrees, which was the same as my arc length out of my circumference, which is the same as my sector area out of pi r squared. And in this case, we're just picking the ones that are convenient for us. In this case, we are looking for arc lengths. We should probably use this one. And we are given the angle in degrees, so we'll go ahead and use these two. So my 250 degrees out of 360 should be equal to the arc length divided by 2 pi r, where in this case r is 5. Solving for that arc length, multiplying by 2 pi r, I get an arc length of 125 pi over 18. All right, very similar idea. Taking a look at number 9 here. Very, very similar idea. In this case, we have a person who is standing on the equator of the Earth. That is them. And we are told that from the center of the Earth, the equator, or the radius from the center of the Earth to the equator, is 3,950 miles. And we are being asked for their angular speed, omega, and their linear speed, which is v-ish. That's what we're going to call it. All right, very, very similar to the last problem. We're still going to try and do that proportional thinking. So coming up with like the fraction of a rotation or even the number of rotations in a particular time span. And then in order to get to angular speed, I'm going to multiply that by 2 pi. This is, again, within a particular time frame. And then for my linear speed, we're going to take that fraction or that number of rotations. And because linear speed corresponds to the circumference, as we rotate, we are traveling around the circumference of the circle. We're going to multiply this by 2 pi r. In this case, because we are talking about Earth's rotations, our fraction is going to be the fact that we rotate once every 24 hours. Not the only way to do this, but a pretty good way, particularly if we are looking for miles per hour, which I do not specify in the question, but, certainly could. That's our fraction. We want to multiply this by the fact that we have 2 pi radians per rotation in order to find our omega. And so my angular speed, I get that this is going to be pi over 12 radians per hour. And then for my linear speed, doing the exact same thing, taking my fraction, 1 rotation every 24 hours, and multiplying it by the fact that each rotation gives me 2 pi times 3950 miles, again, per that 1 rotation. I'm not going to clean this up too much. I'll clean it up a little bit. That should give us 1975 over 6 pi miles per hour. All right, taking a look at number 10 here. We are trying to figure out which of these functions is odd. I will showcase one of these. We did one in class. I'm going to showcase one of these for our review. We are told that g of x is equal to sine of x times cosine of x. And for this, the thing that we need to know is that cosine is even, and that sine is odd. Which is to say, if I plug in negative x for cosine, I might as well have just plugged in positive x. If I plug in negative x for sine, I might as well have just multiplied by -1. So trying to figure out, is this function even or odd? We plug in negative x, and we see what happens. What happens after we plug in negative x? Well, we know that sine is going to let that negative migrate out. So we get negative sine of x. And cosine is going to essentially let that negative fizzle. That negative almost just disappears from cosine. And if we're comparing the current function that we have when we plug in negative x with our original, you'll notice that it is the negative version. We have essentially just multiplied by -1. Therefore, this function is odd. All right, we talked pretty extensively about number 11, so I'm going to just take a look at number 12 here. This may be a little bit better. So this is sine of arc cosine of -1. Now, we do have the ability to do like unit circle stuff with this. I'm going to say, let's pretend we don't see the unit circle way that we could do this. Let's just try this using our right triangle definitions, because that's certainly something that we will need to do, regardless of whether we can recognize this as unit circle. This arc cosine contains within it 2 key pieces of information. One is the triangle information. So the fact that we can treat this as the adjacent side and this as the hypotenuse. And the hidden kind of secret piece of information comes from the fact that this is the arc cosine of a negative value, which tells us that this is actually a quadrant 2 angle. So using our triangle information, it's theta. We know that this is 1, that this is 2, and using Pythagorean theorem, figure out that this is the square root of 3. And so if I'm looking for sine of this particular angle, I am getting root 3 over 2, which is going to be positive because sine in quadrant 2 is positive. All right. One last one from our Unit 4 free response study guide, and then we'll take a look at some of the multiple choice study guide questions. So we are trying to graph, it's number 13, function f of x is equal to 2 times cosecant of 3 times x minus pi over 2 plus 1. Right. Now cosecant, graphing cosecant directly, not saying it's like all that crazy ridiculous, but certainly is going to be a little bit easier if we understand what's going on with its corresponding basic trig function, which in this case, in order to get a better idea of what's going on with cosecant, I'm going to ask what's going on with 2 times sine of 3 times x minus pi over 2 plus 1. We'll go through our standard graphing amplitude period, phase shift, vertical shift, and midline. Amplitude in this case is 2. Period is 2 pi over b, which in this case is 2 pi over 3. Phase shift is going to be to the right by pi over 2. Vertical shift is going to be up 1. And as a result, our midline is going to be y equals 1. We know that sine follows the following pattern. This is going to be mid, then max, then mid, then min, then mid. For our y values, for the max, mid, and min, we know our midline is 1, and adding and subtracting one instance of the amplitude tells us that our max is going to be 3, and our minimum value is going to be negative 1. Our x values that we're going to be accustomed to using, 0, pi over 2 pi, 3 pi over 2, and 2 pi, we need to transform accordingly with these x transformations. Remember, we're always undoing the things that our equation is doing to the x, and we want to do this in reverse PEMDAS order. So for instance, if we look at this equation, the first thing that's happening to my x it is being subtracted by pi over 2. The second thing that is happening to my x is it is being multiplied by 3. And so the first thing I am going to do is actually divide by 3, reverse PEMDAS order, undoing these operations. So I'm dividing everything by 3 here. Pi over 3, pi over 2, and 2 pi over 3. And then I'm going to apply my kind of final undoing here, which is the fact that I am getting subtracted by pi over 2. So I'm going to add pi over 2 to everything. So this is pi over 2. This becomes 2 pi over 3. This one becomes 5 pi over 6. This one is pi, and this one should be 7 pi over 6. So this is pi over 2, pi, it's 2 pi over 3, 5 pi over 6, and 7 pi over 6. Said our midline is at 1. So we'll call this our maximum value of 3, call this our minimum value of negative 1. And set the pattern that sine follows, midline, max, midline, min, midline. Getting something like this. But ultimately, we were not trying to graph sine, we were trying to graph cosecant. And the way we transform that is all of our midline points are going to become asymptotes. And our function is going to flip on its head here. So we got 1 period of cosecant. All right. So that's the kind of initial study guide, but I do want to go over the multiple choice section as well. So looking at the multiple choice questions, number 1 gives us the graph of a polynomial. I'm not going to be super precise here. I'm just going to give the general sketch. Okay. And frankly, okay, I can draw in the XY plane, but actually it's not even like super necessary for this. And that's also not super what is going on. It's more like, sure, something like this. Not exactly, right? But it doesn't really matter. And we are being asked a bunch of different things. First thing is we need to figure out if this is an even degree function or an odd degree function. That has to do with end behavior. We know that even degree functions have ends that agree, and odd degree functions have ends that disagree. In this case, you'll notice we have one end that is trending towards infinity, one end that is tending towards negative infinity. Our ends certainly do not disagree, and so this is going to be an odd degree function. Next option is that f of x has exactly 2 local minima. And I would say that that's definitely true, right? We've got 1 local minimum here, 1 local minimum here. The next one also says that we have 2 local maxima, and I think that that is also true. We've got 2 local maxima at these purple x's. The next option asks, do we have a range of negative infinity to infinity? Because we have 1 arrow that's extending towards positive infinity, 1 arrow extending towards negative infinity. That is certainly the case. And the last one asks about asymptotes. Polynomials do not have asymptotes, so we do not need to really worry about that one. Strictly no. I guess if I wanted to be really tricky with this picture, I would have said x equals 5 as an asymptote, and maybe like y equals -4 as an asymptote. That would have been maybe a little bit of a better question. But regardless, the answer here is certainly not no asymptotic behavior to be seen. Okay. Taking a look at number 2 here, we are being asked to factor x cubed minus 4x squared minus 5x plus 20. Normally, cubics are really hard to factor, unless we can do so by like grouping or something special. In this case, we can do so by grouping. So for instance, looking at these first 2 and the second 2, I'm going to pull out an x squared from my first group, leaving behind an x minus 4. I'm going to pull out a -5 from my second group, leaving behind an x minus 4. I get x squared minus 5 times x minus 4. All right. Next one's just to help us brush up on some of our more niche exponent rules. So we are being asked what is going on with 16 to the power of 1/4. Remember the way that we treat this to the power of 1/4? This is the same as the 4th root of 16. So what number is multiplied by itself 4 times in order to get a 16? Well, 16 is 2 times 2 times 2 times 2. And so the 4th root of 2 times 2 times 2 times 2 is just 2. Similarly, number 4 is asking about, again, some of these weird exponent rules. So this is 3 to the -2. The only thing we need to remember about that negative, exponents cannot make a positive base into a negative number. That negative is taking the reciprocal of my 3 squared, which gives me 1/9. Right. Number 5 is definitely a little bit tricky. So this is log base, nope, yeah, log base 3 of x plus 4 plus log base 3 of x minus 3 is equal to log base 3 of 4 minus x. Using my product rule, I can condense these two into log base 3 of x plus 4 times x minus 3, which is equal to log base 3 of 4 minus x. And using my one-to-one property, dropping our logarithms. Remember, we're using a one-to-one property. We're not like dividing by log base 3 or anything like that. And I'm also going to Punnett square out those two. I get x squared plus x minus 12 is equal to 4 minus x. Solving this as a quadratic, I'm going to move everything to one side, make sure I have 0 on the other. I get that x squared plus 2x minus 16. Whoa. I messed this up. That's fine. Is equal to 0. Yeah, that was supposed to be different. That's fine. Um, Dang. Oh well. In this case, this is a quadratic that does not factor. There are no two numbers that multiply to make negative 16 that add to make 2. And so we are looking for quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This is going to be negative 2 plus or minus the square root of 4 minus 4 times 1 times negative 16, all divided by 2. That's going to give me negative 2 plus or minus the square root of 68 divided by 2. So square root of 68 is relatively close to 8. It's like a little bit more than 8. So this is going to be about, let's call it, so if I do plus, that's going to be like 3.1. And if I do minus, it's going to be about like negative 5.1, just to make it clear that what we've got going on. Plugging these back in, I need to make sure that they are not extraneous. And what I find here is that negative 5.1 does not work, right? If I try to plug negative 5.1 in here, or in here, then I am going to break my function. I cannot take the logarithm actually up here, in here, or in here. I'm going to be taking the log of a negative. That is highly problematic. Cannot do that. But 3.1 works for all of them. If I plug in 3.1, I'm getting all positives. And so I have exactly one solution here, which is 3.1. All right. And my last example here, number 6. Trying to evaluate log base 2 of 32. Remember, when we are trying to evaluate log base anything, we are trying to ask what power do I have to raise my base to in order for it to match the inside. In this case, this is log base 2 of 2 to the 5th. What power do I have to raise 2 to in order to equal 2 to the 5th? The answer is 5. Hopefully this was helpful. If you guys do have any questions as you're working through the study guide, do feel free to reach out. I'd be more than happy to take a look. But beyond that, best of luck with your studying, and I will see you all tomorrow. Take care.